I'm Ed Cologne at the University of Michigan. We use perfSONAR, and I'm the admin, developer, and project lead on this. So in order for me to fulfill all those duties, I had to look to automation in order to be able to effectively do my job. So I'm going to kind of burn through a lot of this. Basically, a lot of you are familiar with perfSONAR scheduled testing workflow, where schedules get published, dashboards and test points pick them up, and they archive them for visualizations. So when we go ahead and provision these componentry, we basically do it where the archiver gets created first, and then the test points and the dashboards are able to send their data to it, and then the schedules are created so that they can get picked up. We have a very extensive infrastructure. We have perfSONAR scheduled scattered all throughout it. We're looking to expand it even further in the future. When I first came on the project many moons ago, one of our first tasks was to bring up about a half a dozen test points. And between installing OSs and doing test point configuration and management by hand and integrating it with the rest of the system, it took us a lot of time. It took us like 3-4 days. We were all intermediate Unix admins, but fairly novice perfSONAR admins. And the other problem we had was the if you break it, you buy it part. So once we got it working, we were all afraid to touch it, because if you messed up the integration between Mad Dash or Esmond, then it could take another couple days of your life to sort those out. So the manual deployment took a number of days for each component. So then we switched over to Ansible, and there's a lot of different reasons why we chose Ansible. It's an industry standard. It's open source. It's agentless. It uses SSH, so that way you're already having to manage SSH as a security hole. This doesn't introduce yet another one. And then it turned the Ansible provisioning into more of an exercise of reading config files that are provided for you as commodity by perfSONAR. It could take you a couple hours, maybe a day, to read through those. And then once you've chosen the configuration options that you're happy with, you can basically tell Ansible to enact those directives onto your infrastructure. And Ansible, you get yourself a cup of tea. While you're doing that, Ansible does the work for you. So we have a security setup here at the University of Michigan, where we have a Bastion host where all the perfSONAR infrastructure is restricted to SSH to that. So on that host, we use TwoFactor there. So the long story short is Ansible is incompatible with TwoFactor. So by using a Bastion with TwoFactor for your Ansible host, your other infrastructure, if it's restricted to that only, basically inherits the TwoFactor. Let's see here. Next slide. So it's important to talk about test points versus toolkits. If you're experimenting with perfSONAR, especially for the first time, or if you only have one, maybe two in your infrastructure, the test point is, or the toolkit's fine. It gives you an additional GUI on top of it. You can install it via an ISO, and part of the problem, part of the thing that's okay for a small implementation, but not really for a wide one, is that each one of these toolkits, because you can use the web interface to do different configuration and scheduling things, has volatile data on the actual toolkit. The test point does not have that. The test point gets all of its information from external sources. So if your test point goes down in flames, you just set up another one and configure it the same way. Let's see here. So you basically, Ansible is not useful for target OS bootstrapping. That you still need to do with traditional means. I know Sean McKee uses Cobbler. There's other different OS bootstrapping methods. But once you have your OS bootstrapped, then you can go get the commodity Ansible playbook from perfSONAR. It has a README that shows you how to get up and running hopefully fairly quickly, and if not, there's help available. Now, the other thing I want to talk about is Ansible task delegation. So when you're running different roles, in this case, I'm going to talk about the test point role. If you control the archiver during the test point provisioning, you can say things like, well, I'm a test point. I want to be able to send my data to different archivers that I have control over. I know what my IP addresses are. So let's just go ahead and set that up right now. So during the test point role, you can actually go out and touch different pieces of your infrastructure in order to integrate the test point or whatever piece of infrastructure you're provisioning with the other infrastructure, so long as you can control it. Let's see here. So you have Ansible Inventory. There's different group vars for, you can have like a perfSONAR group with like global variables for them there. They can be overridden on an individual basis. So if you have a machine that is a one-off that has a special configuration, you can put that as a specific host variable, which has a higher precedence. And the host file basically is a method for describing each one of your pieces of infrastructure and which roles it shall inherit. So there's variable precedence. This is a fancy way of saying that it goes from the most generic to the most specific. So if you can set up your infrastructure and say, hey, I want this to be my generic definitions, and for individual hosts, I want to have these specific definitions that override it. You have inventory, you have your group and host variables. They live in different directories. You have an inventory directory. It doesn't always have to say inventory. You can have multiple inventories. So at University of Michigan, we have a mobile project. We have a couple of labs. We have our core. So we have different inventories for each one of them. You could choose to put them all in a single inventory, but instead our strategy is to separate them out here just for, for convenience and for sort of like, just to be more specific. Let's see here. The host file, the one that gets distributed by perfSONAR, has test points, toolkits, archivers, and the other infrastructure. Basically, what you do is you set up your machines with your base OSs. You make sure that your controller can SSH into them, and then you add them into here. Now, one big difference between perfSONAR bundles and perfSONAR Ansible is that the bundle supports the management bundle, the central management bundle, which basically bundles mad dash, psconfig publisher, and the archive Esmond all as one. We, on the Ansible solution, have made those discrete. So if you want to have a discrete mad dash versus a discrete publisher, you can go ahead and do that. So you have the local inventory, which is easy to implement. Basically, you just take the files provided for you and you fill them in. You're up and running quickly. What instead we've chosen to do is we make individual inventories for each one of our projects. And what that allows us to do is we can save that individual inventory in source control. So all of our information is in Git. Our disaster recovery is really nice because if something bad happens, all we do is we just go, bootstrap a machine with Ansible, go drag down out of Git the configuration for whatever answer for perfSONAR implementation we want, and then we just rerun it. And on top of that, there's each institution we've discovered has its own, unsurprisingly, has its own security and bootstrapping procedures. So our first step here at the University of Michigan is we run our bootstrapping playbooks against the same inventory that we use to run against the perfSONAR stuff. So you can use that, you know which machines you have, you have to bootstrap them, you go ahead and do that, and then they're ready for your, the first step's OS, second step is institutional bootstrapping, third step is actual perfSONAR installs. We have a number of roles for each piece of infrastructure. We have a concept of inheritance. They all use the same installer, so they all go to the perfSONAR repository. The toolkit basically rides on top of the test point. So this is sort of the inheritance that we use here. The installer installs base OS updates. It supports CentOS and Ubuntu. It's got, it helps, it configures your repos, installs your main software bundles. This kind of happens behind the scenes. You don't really see all this happening. It's just provided for you. The archiver is exactly what is the Esmond archiver. It installs Esmond, and it allows you to add a static list of IPs. More on that later. That's not the only way to get a machine into the Esmond, or to be auth to Esmond. We'll talk about that more in a little bit. I would say talk about it now. How about that? So this is more about task delegation. If you own everything, if you own your test points and you own your archiver, basically you don't have to do much to your archiver. Instead, you tell your test points, go ahead and authorize yourself to the archiver. If you manage the test point, but you don't manage your the archiver, you have to add the test point to, excuse me, if you don't manage the test point. So like, let's say we had a collaboration with Indiana University and they were running some schedules and wanted to put data in one of our archives. We would add them to the variables in the Esmond role. So if we own everything, they go in the test point role and say, hey, author yourself to our archivers. If we don't own the test point, then we can add them into config file for the archiver on our end. If you don't own the Esmond archiver, then you have to reach out and you have to say, hey, could you please add our machine to it? You know, and that's the old school way. Everybody's doing that right now already. So the test point, it basically installs the test point. It does some extra security things. It has the ability to auth its IPs to any archivers that you control, checks for running processes, and it runs a pscheduler troubleshoot to verify its functionality. Let's see here. Next slide. So we have another kind of like check down for JSON mesh config files. If you don't manage a test point that you want to inhale one of your JSON config files, either through psconfig publisher or PWA, you basically have to get to the admin of that test point and say, hey, here's your URL. This is how it's done today already. So you're probably familiar with that. If you do manage the test point, but you do not manage the schedule publisher, you can add that URL into your PS test point variable, and then your PS test point will pick that up via Ansible. So you just add that to your Ansible directive, as a static link, your test point will pick it up, or Toolkit. Now, if you own both your test point and the schedule publisher, you can basically add directives in either the publisher or the PWA role that say, hey, whenever there's a schedule, a new schedule or whatever, go ahead and push it to all the test points that you're aware of. So your test points don't even really need to be aware of the changes. They just get pushed to them. The toolkit is the test point with the GUI on top of it. I'm really burning through my time here. Let's see here. The mad dash, let me see here. Did we? All right, mad dash is the archiver, excuse me, is the visualizer you're using right now with Esmond. And it's got basically the same rules where the more of it you own, the more of it you can rely on automation just to do your work for you. If you don't own any of it, it's a manual process. If you own partial of it, now it changes the slides. If you own a partial bit of it, you can still rely on automation by putting URLs into the mad dash directive. So in the best case scenario where you own everything, basically you just tell the configuration publishers, either PWA or psconfig, to push it to, you know, dashboards and test points. psconfig JSON publisher, that is what we just talked about. So we've got a Bootstrap Playbook. Basically, you clone the playbook. You go into the playbook that you just cloned. You go get the dependencies, which are the component roles using Ansible Galaxy. It's, you know, just a one command. You go into, I think, so you create the inventory. Sorry about this. My computer's flipping through my slides for me. You can use a program called defaults.sh to prepopulate your inventory. And when you prepopulate your inventory, it basically copies in all of this componentry configuration into your group vars. So this will take effect unless you override it for all of your perfSONAR infrastructure. You basically at that point can go into here and component by component, you make directives. And you don't even make directives. They're provided for you. You basically just choose options. And then after that, if you want to override any of those options, or if you want to add LS registration to any of your hosts, you can go ahead, like here's an example of if you have a test point and you want to override the global definitions, for that host name, you put in the test point YAML, and then you make different directives, which will override them. And you can also add a ls registration.yaml, which is provided for you in order to, because ls registration is unique basically to each host. It has host specific information. Once you do this, you can run the playbook. There's different options for ways that Ansible interacts with the target host. I don't think I have a ton of time to get into that. Basically, once you've done this, you turn what was a 6-day process into basically a day process. And then once you've got this done, you also have disaster recovery and repeatability on top of it. So it's sort of a one-time cost. Let's see here if we can get to my next slide. Also, on top of this, we have distributed with the playbook currently, we have a sample Vagrant environment where my computer is hating me right now for some reason. There we go. So the Vagrant comes bootstrapped to have one archiver, the Esmond archiver, a CentOS box, and a Ubuntu 18 box that we're using as test points. So then we have near the bottom of the Vagrant file, different directives that, oh, please. So basically down here, this is sort of like an Ansible inventory. You basically take the directives that you would use in an Ansible inventory, you put it in here, and then when you type Vagrant up, it creates that infrastructure and allows you to interact with it in sort of like a test environment. So to that end, I'm going to quickly share my screen. And I'm going to show you here that I typed Vagrant up. And this is the Vagrant file that I showed you earlier, where they had those directives. So now I type Vagrant up, it provisions the boxes. Here you're going to see Ansible output. Basically, it's going through here, installing test points, archivers, integrating them. Ansible's output's a little cryptic, in case you couldn't tell. So down here, you can basically see that it's run through here. Oh, I picked the wrong window. This one here had an error in it. But the end result, you can see over here, is that when you're done, I was able to say Vagrant SSH into the CentOS 7 box. And then I was able to do a pscheduler task throughput to the Ubuntu 18 box. And you can see here that in the virtual environment, it ran the throughput. So you can test your configurations here painlessly and see that everything works the way you intend. Let's see here. Let me go back to my presentation. Let me know if you can't see that. Next steps, there's a bunch of different improvements. I'm not going to go through that right now. I don't think I have a lot of time. We're going to have better Docker support. Now, I'm going to completely switch topics here. We also use pScheduler to monitor Wi-Fi here at the University of Michigan using a program we call pSSID. Basically, it is run on a Raspberry Pi. The Raspberry Pi runs perfSONAR along with pSSID. It scans the area for SSIDs and pSSIDs. If it finds some pSSID SSID combo that it's configured to recognize, it runs different perfSONAR tests against it. So you have a testing architecture where you have Wi-Fi scattered across your campus. It goes back to a data center and then eventually out to the web. One of these probes put in the university building or whatever infrastructure you're supporting can talk to multiple access points and then do end-to-end tests to your data center and out to the greater internet even. So if you have multiple access points with mixed coverages, it can detect rogue SSIDs, which are SSIDs that you don't necessarily provision and you want to know about. It can detect BSSID channel mismatches. You could say, for instance, I'm expecting my BSSIDs on this channel. If you don't find it on that channel, you find it on a different channel, you can warn about that. You can also say that you can expect to see n number of pSSIDs in an area. And if it doesn't, then it can assume, you can make an assumption that perhaps some of them are offline, and that would be insufficient coverage, and that could also trigger an alert. That's sort of passive testing. The active testing is the full gamut of perfSONAR tests. You can run latency, you can run throughput, and each one of these isn't run just through the SSID in the area. It's run through individual pSSIDs. So you can get a granular, you could have one pSSID that's performing well and one that's on the fritz, and you can determine which one is which. So let's see here. These are what we're setting our information into ELK. We've created some dashboards. You can see here that we've detected some rogue SSIDs. Here, there's some channel mismatches, things to be able to warn your techs. I'm going to burn through this stuff here. If my slides could ever catch up with me, I don't know why Google's or my browser's doing this. So these are just examples of the dashboards. We're using what we call armored Pis. They're Raspberry Pis with an off-the-shelf case that basically covers all of their ports except for the Ethernet. They have a power over Ethernet hat, so it's a one connection monitoring device. You plug in your power over Ethernet, and you're off to the races. For a complete probe, they cost about $100. They use our RPI4 with a PoE hat, a 64 gig card, and the case. And then you do all your OS provisioning and all of your interacting with the Pi over the wired interface, and it sends back data via the wired interface, and the wireless interface is used for testing. So we've developed that here. It was a group effort. Some of the core perfSONAR people have done it, and some people here at University of Michigan as well. So now that I have burned through my slides and my voice, I would like to know if there's any questions.
Ed, there are a couple of questions in the
Sure.
chat. So one is, it's about Ansible. So would that work for Alma as well?
Excuse me?
Would the Ansible playbooks work for Alma?
All the Linux said.
Oh, right now we support natively Ubuntu, certain flavor, whatever is currently natively supported by the perfSONAR consortium in terms of bundled distros are the ones that we support. You could run this against it, and if it worked, more power to you. If it didn't, then it would not necessarily fall under our support umbrella. It obviously, as we have discussed earlier in the presentations today, the OS of choice is a moving target at the moment, and we intend to support whatever official OSs are deemed appropriate for core perfSONAR. We will also support them with Ansible. The short answer is no. We don't support Alma out of the box now, but it could work. How about that? So,
thank you. And there's a second question. If let's say a mission goes down, so is the question is whether it would be replaced using Ansible or using the backup of the machine itself.
Well, we don't really backup machines here anymore. Instead, we view the machines as commodity. We store the only real volatile data that we store is measurement results. All of the schedules are stored in Git and are so if we provision a schedule publisher, all the OSs are done by hand currently or by cobbler, and then once that's done, we run Ansible against it, and that will provision the infrastructure, but we also have a configuration provisioning portion. So for instance, the schedule publishers, the schedules are stored as JSON somewhere. So we can drag them down out of source control and repopulate them if they were the ones that died. In terms of test points, it's the same thing. We get a new test point, we stand it up, we stand the OS up, we point Ansible at it, and it assumes the role that the old one that went down in flames takes. So there used to be like sort of this concept of like a gold disk ISO or a master or whatever, master image. And Ansible sort of gets away from that, where instead of backing up your infrastructure, it treats it as commodity. You just basically replace it with something new, and you reconfigure it the exact same way the old one did. So you, aside from backing up volatile measurement data, which you can't replace, if it's configurable at all, you store the configuration, and then you basically just treat hardware as commodity. I hope that answers it.
Yeah, thank you. And there's actually one more question. So is there a link to the code for pSSID?
There is, but I'm a little reluctant to release that right now. Right now, we're doing an alpha deployment of that at the University of Michigan, and we're kind of working out some of the kinks. In fact, Mark sort of alluded to this in one of his earlier talks. perfSONAR did not support some of the operations necessary to monitor Wi-Fi, mainly like, pSSID scanning, connecting at layer 2 with 802.1x, and then like asking for DHCP leases. And so we had all that built into to pSID, and it made it a bit complicated. So one of the things that we did over the summer was we had an intern project where we migrated those functions out of pSID and into pScheduler. So right now, the newer, Mark can correct me if I'm wrong, but the newest versions of pScheduler, if you look under the hood and look for the tests, you'll find that it supports pSSID scanning and DHCP and layer 2 auth. So
that'll be in 5, Ed. Yeah,
that'll be in 5. So you're gonna have some real neat Easter eggs coming up here. So what we're doing is we're redoing pSID so that we remove the operations that do that, and instead we're going to rely on pScheduler. The other major thing we're going to do is right now we have this concept where we ask pScheduler to do something, and we wait for pScheduler to finish, and then when we get the result back, we do the next step. Well, we're going to replace that with Mark's batch processing stuff. So basically, pSID is going to run on a cron style syntax. And let's say you say every hour I want to check my APs for latency and throughput. What'll happen is on the hour, it'll scan. It'll say, okay, I found all the APs. This list of APs, the subset is the ones that we're looking to test. And then we'll hand pScheduler a batch blob that'll say, do level 2 auth, get a DHCP lease. If they succeed, then do throughput, latency, check DNS on these servers, check connectivity, web connectivity out to Google, and do check on NTP to see if you can reach these NTP servers. And at that point, we don't have the we don't need to do the orchestration. We don't need to tell pScheduler do this and then do that. Instead, we just hand the whole blob to pScheduler, and pScheduler figures it out. If it can do any of this stuff in parallel, it will. If it's like a throughput that needs to have exclusivity, it needs to be run exclusively, then pScheduler figures that out. So we're going to greatly, by migrating the 1.0 pSID functionality into pScheduler, we're going to slim down pSID, make it less of a support nightmare, and then we're going to release it more widely. We're currently in the alpha deployment here, and we're learning a lot of lessons. I would have preferred to have had it released before this, but like Joe and I talked about earlier, transient internships and COVID and other things have slowed down our development process here, but it is coming.